Welcome to another episode of Tech Interview Live Coding. In this video, we are going to learn how to apply breadth first search on a binary tree. So stay tuned and let's get right into it. Hey guys, this is Sengineer bringing you the best tips and techniques that you can apply during your upcoming technical interviews. If you are new to this channel, don't forget to give it a like and subscribe so you don't miss more future videos just like this one. Enough talking, let's get right into the question. Today's question is Leetcode question number 102, binary tree level order traversal. It is of medium difficulty. It got a ton of likes and a few dislikes, meaning a lot of people found this problem very helpful. So let's read through it together. Given a binary tree, return the level order traversal of its nodes values from left to right, level by level. So for example, if we are given a tree that looks like this, we are going to go level by level. And in the first level, we are going to return only one element, which is 3. And in the second level, we are going to return 2 elements, which are 9 and 20. And in the third and last level, we are going to return 2 elements again, which are 15 and 7. So the return is going to look like this. In fact, this question is something that teaches you a very important technique on graph, which can also be applied to trees, given that what forms a tree would also form a graph. There are 2 ways of traversing a graph, depth first search and breadth first search. And in this video, we'll be applying breadth first search technique here. Breadth first search meaning we go level by level, we start from the root, we traverse its direct neighbors, and then we traverse nodes which are 2 hops away from the root, and so forth. Typically, implementing breadth first search makes use of FIFO queue data structure, first in, first out. We are going to use a queue in the following way. First, we push the root node to the queue, and as we go on a loop per each level, we pop out all elements in the queue and push all their children back to the queue so we can traverse them in the next iteration. And as we are popping out elements in each iteration, we record them in the list that we are going to return at the end of the method. And we do it until we have no more elements to pop out from the queue. Alright, let's drop some codes and check out how it actually works. So first order of business here is to create a variable that we are going to return at the end of the method. So let's call it ret maybe, new array list. And then at the end of the method, we are going to return this. And let's do simple null check here. If root is null, if a given root is null, then we are going to just return empty list basically. Now we are going to make use of queue, which holds elements of 3 node data type. We are going to call it queue. And then in Java, linked list implements queue interface. So we can initialize like this. And queue is going to have 2 very important interface methods that we are going to use. One is offer and the other is poll. Offer meaning we are going to add something to the queue. Poll meaning we are going to pop out something from the queue, first in, first out. Now we are going to offer root node to the queue, and then we go on the while loop. We are going to iterate over the queue until the queue becomes empty. So if queue is not empty, we do while loop, fair enough. And before we go on each iteration, we first record the size of the queue. This size variable right here simply tells you how many nodes there are in each level. So we are going to pop out exactly the number of elements per each level. So we have for loop with the size variable. And then we are going to poll an element and then call it current maybe, queue.poll. And then we are going to add their children back to the queue so that we can revisit them in the next iteration. So let's have that. If current.leftChild is not null, we add that to the queue. And we do the same for current.right. Copy and paste. Brilliant technique. Alright, things are looking good. Now we just need to update the return variable as we go on each iteration. So let's have that. Before going into the for loop, we are going to first create the list of integer. Say list, new array list. And as we pull 3 nodes from the queue, we simply record their values and add them in the list variable here. So let's have that, list.add current.value. Or we should have called it val since that's how they define tree-node class right here. So let's call it val. And then at the end of the for loop, we are going to simply add this list to the return variable, red.add list. Now that's about it. Let's submit this and see if it actually passes. So hold on a second, it's gonna, all right. As you see right here, our solution actually passes all the test cases. So why don't we summarize a little bit? In this video, we took a look at how to apply breadth-first search on a binary tree. In order to do that, we made use of queue. First, we added root node to the queue. And as we go on each iteration, we recorded the size of the queue, which means how many nodes there are per each level. And as we go on a for loop inside of the while loop, we were simply pulling 3 nodes out of the queue and adding their values to the list. And that list had values for all elements in a given level. And then at the end of the for loop, we added that list to the variable that we are going to return at the end of the method. Alright, that's about it. If you found this video helpful, give it a like and subscribe, and I will see you in the next video. Bye!